Hi everyone, this is Sahil here. Today I'm going to give you an in-depth understanding of the method which literally revolutionized the IT industry and other related services. Yes, it's virtualization technique. So coming to virtualization, what is virtualization? Virtualization is the process of running a virtual instance of a computer system in a layer abstracted from the actual hardware. Most commonly, it refers to running multiple operating systems on a computer simultaneously. Applications running on top of virtualized machine seems as if they are on their own dedicated machines. It creates useful IT services using resources that are traditionally bound to hardware. Provision of a virtual view of computing resources turns one server into a host for a group of servers that share the same resources. So consider this real world example. Here it's a ship or a boat moving in a ocean or a sea. So here we can visualize its position and its path easily through the concept of virtualization. This is very critical when come to defense applications, etc., where you want to predict the path or position of an enemy object, or etc., moving in the space. So why virtualization? It allows exploitation of full capacity of a physical machine by distributing its capabilities among various users or environments, hence enabling faster and broader business capabilities. It gets rid of IT rooms, cables, bulky hardware, thereby reducing the overall IT overhead as well as management costs, hence enabling faster service provisions. It usually improves the overall performance due to technology that can balance resources and provide only what the user needs. It has minimal downtime. Well, downtime normally disrupts the productivity of development, as admins can run multiple redundant virtual machines alongside each other and failure between them when problems arise, so thereby solving that downtime problem. Easier resource management and better resource efficiency as it allows automated IT service management workflows. Here you can see how it works. Here, if we consider this as a desktop system, it's running on Ubuntu. In this same system, you can have three different operating systems. Here it's same. Otherwise, if you want to use it as if you want a Mac OS, if you want Windows, if you want some other OS, Amigo OS, or etc., it's also possible through the concept of virtualization. We can run all of them in the same machine by exploiting the hardware and the software capabilities of this machine. Here you can see the difference between a normal traditional computer system and a virtual machine. Here the virtual machine monitor gives access to the guest operating systems for the physical computer hardware, while in the traditional system, the operating system is responsible for providing access and allocation of resources to the applications which are running on it. Now coming to how it works. When a hypervisor is used on a physical computer or server, it allows physical computer to separate its operating system and application from its hardware. Then it can divide itself into several independent virtual machines, and each of these new virtual machines can run their own OS applications independently while still sharing the original resources from bare metal server, which actually manages the hypervisor. Those resources include memory, RAM, storage, etc. Now, this is the traditional architecture of a computer system, where the applications run on top of the operating system. Where the operating system gives access for the applications to the computer hardware. While coming to the virtual architecture, in virtual architecture, the virtualization layer, which lies in between the hardware and the operating system, is responsible for the allocation of resources and access to the operating system to use the computer hardware. Now, what are virtual machines? It's the emulated equivalent of a computer system that runs on top of another system as they cannot directly interact with a physical computer. It have access to any number of resources ranging from computational power, memory, connected devices, such as USB drives. If stored on a virtual disk, this is often referred to as a disk image. A disk image may contain files or a virtual machine to boot, or it can contain other specific storage needs. And hypervisors responsible for allocation of resources, the VMs, and keeps each separate from each other without any interaction in between. Now, what are hypervisors? It's a software layer that coordinates VMs that are present in a system. It serves as an interface between the VM and the underlying physical hardware, ensuring that each has access to the physical resources it needs to execute. It also ensures that VMs don't interfere with each other by impinging on each other's memory space or computation resources or compute cycles. There are actually barely two types of hypervisors. There are type 1 or bare metal hypervisors and type 2 or hosted hypervisors. So here we have done a comparison between the type 1 hypervisor and the type 2 hypervisor. Coming to type 1 hypervisor, it interacts with the underlying physical resources, replacing the traditional operating system altogether, while the type 2 hypervisor runs as an application on an existing OS. Type 1 hypervisors, they are most commonly appear in virtual server scenarios, while type 2 hypervisors mostly used as an endpoint devices to run an alternative operating systems. Type 1 hypervisors are more secure and have less latency and are operating systems for themselves. But type 2 hypervisors, they are actual instances of guest VMs. And coming to type 1 hypervisor, there's no software operating system in between, hence the name bare metal hypervisor. While type 2 hypervisor are found in environments with less number of servers. Examples for type 1 hypervisor can be Oracle, Virtual Machine, KVM, etc. While for type 2 hypervisor, it can be Windows, Virtual PC, VMware, Fusion, etc. So, what is VMware? It's known for its virtualization and cloud solutions where VMs are created and run on a hypervisor that allows multiple guest instance or OS to run on a single hypervisor simultaneously, and each instance can run single or multiple applications at the same time. VMware tool helps to maintain the VMs and browse the web with a high configuration rate. The application is beneficial in setting configurations for running projects efficiently. Machine learning is an exact feature of this tool. Helps in software development and browser testing. It provides product demos where all technicalities can be met and damage, if any, can be easily recovered. So there are different types of virtualization. So virtualization include desktop virtualization, network virtualization, storage virtualization, data virtualization, application and data center virtualization, CPU and GPU virtualization, Linux virtualization, and cloud virtualization. So what are its applications? So it enables cloud computing services which are cost effective and hardware reducing and energy saving. It is used to create realistic learning environments for digital forensics that reduce cost and space requirements. It leads to high performance and efficient servers which are backbone of solid IT infrastructure. It provides it has provision to create virtual networks for logical switches, routers, firewalls, load balancer, and virtual private networks, VPNs, commonly known as VPNs. We can even consider IP addresses, DNS, resource access through web servers, API gateways, masking the endpoints, meditation, etc. So now I'm going to take two particular examples of how virtualization helps in setting up data centers and behind it the working of data centers and how virtualization plays role in cloud computing. So coming to data centers benefit from the virtualization because of the ability to run more services and software in a smaller footprint. Public cloud computing is all about accessing services and resources from a remote data center and only paying for what you use. Visualization and high-speed networking truly enable the era of cloud computing. As you can see, the local computer system being connected to the public cloud provider or the data center through internet. Now, virtualization in cloud computing. This is the VMware infrastructure consisting of local systems connected to the virtual machines in data centers through internet. Now, virtualization plays a very important role in cloud computing technology. Normally, in cloud computing, users share data present in the cloud like applications, etc. But actually, with the help of virtualization, users share the infrastructure. The main usage is to provide the applications with standard versions to their cloud users. Suppose if the next version of the application is released, then cloud provider has to provide the latest version to their cloud users, and practically it is possible because it's more expensive. To overcome this problem, we basically use virtualization technology. By using virtualization, all servers and software applications which are required by other providers are maintained by third-party people, and the cloud providers has to pay the money on monthly or annual basis. Virtualization technology provide a virtual environment for not only executing applications, but also for storage, memory, and networking. It can be used to perform various tasks such as data integration, business integration, service-oriented architecture, data services, searching organizational data examples. So coming to what's the difference between virtualization and containerization? Virtualization actually enables you to run multiple OS on the hardware of a single physical server, while containerization enables you to deploy multiple applications using the same OS on a single virtual machine or server. Virtualization it's not portable, while containerization is possible. Virtualization has hardware layer isolation, so the feed is well secure, while containerization has process level isolation. Virtualization have longer life cycle in comparison and best used for longer time, while containerization it has faster setup time and they are better optimal for shorter life cycle tasks. It's great for supporting applications that require an OS full functionality when you want to deploy multiple applications on the server by the virtualization technique. While containerization are better choice when the main priority is to minimize the number of servers that have been used for multiple applications. Now coming to security. Virtualization offers some security benefits. For example, VMs infected with malware can be rolled back to a time when the VMs was uninfected and stable and can easily delete and recreate. It's not at all possible for a non-virtualized OS as the malware affects the core components of the operating system. If an attacker manages to compromise a hypervisor, he or she will be potentially able to own the VMs and the guest operating systems. Because hypervisors can also allow VMs to communicate between themselves without touching the physical network. It can be difficult to see the traffic and hence it's difficult to detect the suspicious activity. It's a major cause of concern for the virtual machines actually. Coming to the market also offers various virtualization security products that can scan and patch VMs for malware, encrypt entire VM virtual disk, control and audit VM access, etc. Now coming to the disadvantages of virtualization, it leads to resource exhaustion, lack of visibility and control of virtual networks. Could be vulnerable when users don't keep them secure and can overrun storage network. Frequent software updates can make it difficult for backup at times. Cannot lend the same performance monitoring as hardware like mainframes and hardware drives do. Compatibility issues can be time consuming and difficult to solve. VM sprawl, unchecked growth of VMs can cripple an otherwise healthy environment. Resource distributions and partitions can result in varied ways and features. It can be different in various guest OSs that are running on the same virtual machine. So, when to virtualize? That's a big question in the tech industry right now. If you rely on technology for services and software development, then you have need for that. If you can cover up the cost considering the return on investment rate, the return you will get after implementing the virtualization service. And if you want to save space by better use of the existing space that's available in your office or in your surrounding. And if you have more number of employees, say 20 plus, and if you want to reduce maintenance and hardware costs which are needed for maintaining huge servers, cables, etc. Now coming to the future scope of virtualization. Automation in industries, augmented reality, virtual reality, etc. has been the brainchild of the virtualization technique. Potential of virtualization is vast in the IT domain, including virtual servers, virtual storage, hybrid hypervisor, open source based tags, etc. It's a stepping stone for greater developmental success in the industries as possible. More and more computing devices and computing gets virtualized. With the virtualization revolution getting wider hands through cloud technology, the scope of visualization and the expansion is limitless. Nowadays, security virtualization is considered as one of the critical technological leap in the field of virtualization as a whole. Now, I'm going to talk about an emerging technology, edge computing. Even though it's presently there, the scope of this technology is wide enough. Edge computing. So it's a part of a distributed computing technology in which information processing is located close to the edge. That's where things and people produce or consume the information. It was developed due to the exponential growth of IoT devices to cater the challenges posed due to latency issues which can affect the performance of the application. Here, cloud computing plays a critical role through internet connectivity for either receiving information from the cloud or delivering data back to the cloud. An edge gateway can process data from an edge device and then send only the relevant data back through the cloud, thereby reducing the bandwidth needs. It's clear that while the initial goal for edge computing was to reduce bandwidth cost over long distances, but the potential of the technology will definitely grow over the coming years. Here I've given a diagram of how edge computing works. Edge computing basically allows data from Internet of Things IoT devices basically to be analyzed at the edge of the network before being sent to the data center or cloud. You can see that Internet of Things IoT devices connected to the edge where the local processing takes place before being sent to the cloud or data center for further processing and for extracting much details.